Hello there, now we're going to start with how to connect the OPTA MODBUS, make it into a master and connect it to the Finder 6MBU and the 6MTA. So the first thing to do is create a new project. Let's call it MODBUS Master 6MBU. So we know what it is, and we need to show that into a folder on the laptop or your PC, not in the cloud. Doesn't seem to like being in the cloud. So once you've opened the PLC Arduino software up, first thing to do is set up the communications as we would with anything else. So go to the properties, and this is set up on COM8. So cool, it's on COM8. We'll just set this to COM8 just for completeness. So now what we need to do is set up the resources. So we're going to need an LED for this project, +1. So all we do is type in, we'll just call it LED1. We don't need to do the rest, but like you do with anything else on the Opta, you have to justify all those. And the same with if you need to use the button or the relays, do that. So that's the only physical thing we need on the Opta to just basically show what's going on with the output. In the Ethernet, in the sketch, sorry, what we need to do is, if you open the sketch, this is where we'll set the IP address of the Opta. So what we need to do is just take out the / and the star, which will sort of just take the note out and the star and the /, just so you've got those things out. And this is where you're going to put the IP address of the Opta you're going to use. Ours in the 192.168.1.111 range, and we're calling our Opta 6. And here we need to make the gateway in the same realm. So that's going to be 101, like that. And here you put we put zeros in for the DNS to make sure there's no DNS automatically detected. So that would set up, so basically your IP address for your Opta is 192.168.1.1.106. That's in our realm. Just make sure that matches your network, not ours. So that's what you need to do for that, for the Opta for that. And then if you go look, we've got Ethernet. If you click on Ethernet, you'll see we get a little we need to click on MODBUS Master in this box to say that we want the Opta to be a master. And then we go back to resources, Ethernet again, and right mouse click this time and click on add. And you'll see that we've got the option of adding a generic MODBUS slave. So generic MODBUS, if we double click on it, it seems to disappear, but if you go back to resources, you'll see under Ethernet we now have generic MODBUS. So if we double click on the generic MODBUS, we can now change this name to 6MBU. So, and we need the IP address of the 6MBU, which is set up in other videos, and in this one it is 192, sorry, .168.111.110. That's the IP address of our 6MBU, and we know the address is MODBUS possess is 1 on this size, and timeout period we'll make that a second. Okay, so I'm with MODBUS, so that means we've now got something called 6MBU in Ethernet. We've set the Ethernet on the master. We've set the 6MBU up as a slave with its IP address, and now we need to read the values. So to read the values, what we need to do is every address register as an address, and in the 6MBU, if you look into the 6MBU MODBUS protocol structure document that's available on the website, you'll see that we can read things like the RMS voltage, the RMS current, etc., power, reactive power, and everything has its own address. So for the current, which we're interested in today, the current is it's a 32-bit float word. It does the most significant word first, and it reads the current in milliamps. So these would be address 135 and 136. So we would read as it's swapped. What we need to do is add read a holding register. So once we've added the read hold register, what we need to do is parameterize that. So if we go back into the parameters here, we'll see here we need the address, and the start address for the IRMS is 136, which is the highest number of the registers, and we'll do it every 5 seconds. And as you can see, it's address 136, and we can put a label in here. Now in the document it actually uses the following, and this time after it I'll just put the word high, so I remember it's the high number. And here we actually set that to real. So this is the name out of the protocol structure document. We're going to call it real because it's a real number, and it'll pick up 32 bits, the whole word. We click on OK, and then so that's the top number. Then we go back to the 6 MBU, highlight it, right mouse click, add, again the 03. So you can see we've got Modbus 1 and 2. So the second one, if we go to it, you can see it's blank, and this would be address 135 because it's the lower number of the two. 500 milliseconds, so every half second, and again it's I underscore RMS underscore SW underscore, and this time I'll call it low, so it's the lowest number of the two, just to remind you. And here, instead of using word this time or real like we did last time, I'm going to use int, because it's just one word we're looking for, and it just reserves it for the read value. So now we've got Modbus set up. We've got to read the values from the 6 MBU. We've got the it's set up here for the the IP address of the Opta itself. And then in projects, what we need to do is we need to add another little global variable. So if you go to global variables, if you right click on where it says CNT for count, and then well, double click actually, it'll open up another window, and you can right click in the yellow box and click on insert. And here we're going to put a result, which is just we're going to do some maths, so we need a result somewhere to put it, and instead of Boolean, what we need is to be able to put it down as real, so it's a real number, because the output of the number could be up to 32 bits, so we want a quite big number. So that means we've now set up in resources our IP address for the Opta, our slave addresses, our LED, and in projects we've set up a new maths result for result, so we can open a new program. So again, to the top, click on add, new program, function block, and we'll call it master. And we'll assign it to the fast level of the program. So that'll bring up your programming line. So as you can see, programming line here, which you'll be used to. So the first thing we're going to put in is the variable that we're reading from the Modbus, which in this case is I. And as you can see, we'll go for I high, I RMS switch high. So we'll put that in, and that's what we're going to read from the Modbus registers. And what we're going to do is we're going to divide that by 1,000, because this comes in milliamps, and what we want to do is have the number in amps. So if we go across the library tree and operators and blocks and arithmetic, and go to div for the divide and put it across there, we can connect that together. So we're putting it into divide, and obviously we need to divide it by 1,000. And to do that, we click on K for constant, put a constant in. As you can see, that's 0. We can connect those two together, and in the 0 we shall type 1,000 to convert milliamps into amps. So that will give us an output here, and what we can do, as we've done the result, we can put here, and if we type we'll see result appears. Click on OK, and then this will put it in backwards. So again, if you right mouse click on it, you can switch direction so you can see it, and here we've got the result of that calculation. So it'll be milliamps divided by 1,000, so this will give you 2 amps here. And with the heater we're using, it should be around 2.6 amps to do that. Now, to be able to turn on an LED to say it's the heater's on, what we need to do is do a compare statement with this. So if we go to the library tree and we go further down and see on comparison, we can do greater than or equal to. So if we bring that into the program, we can actually connect we can actually connect these here to here to here. So we've got the value coming in from the result to compare it to. And what we need to do now is put another constant in just to compare it. And what we're going to do is compare that to number 2. So if it's over 2 amps, we're going to put the LED on. And to put the LED in, what we need to do is go to the resources, and you've got your LED outputs. Sorry, the project. You've got your LED mappings, and we drag this in to the program that's disappeared. So we'll find the program again. There we go. So project, drag the LED in, drop it in, click on OK. Again, right mouse click to switch direction and put it in there. And what we should have then is we have the input here divided by 1000. That comes out to here. Should be 2.6-ish when we turn the heater on. We'll look at it 2, and if the heater's on, the LED should come on. So what we need to do now is we go to online connect. So as I can see, it's connected to the OPTA, but it's got different code in it. So what we're going to do now is download that program. So if we go to online and download code, it needs to be compiled. So we send yes to it, and as we're sending that down, you'll see it starts to compile. Now this can take quite a while, and this can take up to 10 or 15 minutes for the first time you do it. So this is could be a long time. But it's usually sort of within the 4 or 5 minute range. What also does happen is that this is worse for the first time you've done it. So this is a new program, so it's worse for us to do it this time because it's compiling all the code, etc., for the OPTA to send it into its memory locations. When we do shorter programs in the future and do little changes, it won't take as long to do this. So it can be a bit frustrating the first time, but as long as everything works correctly, there's absolutely no problem. Just while we're on that subject, it is important to keep your output box visible while using the OPTA, because some of these times are quite long for compilation. It looks like if you can just see the compiling sketch, nothing's happening, but actually you can see the data scrolling through on the outputs to ensure that things are happening in the background that you're not aware of. So it's a good time to go and get that cup of tea that you've been promising yourself. Just in case there is any errors or problems in the future in it, it will give you error codes. And to source those error codes, if you go to the help menu at the top and click on the index key, it will take you to the PDF of the help files, and from page about 240 onwards to the back of the file, there is actually a list of all the error codes and what causes them, which is a very good use of useful resource for you to look at. And also in that booklet, there is towards the back half an explanation of each of the function blocks, what the function is, and an example of how it would work, and what you should expect to get from an input and an output in that product. You probably my window may look slightly different to yours, and that was because the windows at the side can be pinned to keep it clear. So on the left hand side, I've got my project files, so I can look at all my programs and variables. The resources to make sure I can parameterize all the variables, like the LED inputs, the physical inputs on the OPTA and the outputs, and also that's where you'll see if you have any of the expansions connected to it. They will automatically appear there from an internal scan. And on the right hand side, I keep all my programming files, so the library file where I'll find all my function blocks, like these two. These are all found in here for the list, and the catalog tells you what you've got connected. So things like the expansions will appear there, and then the properties windows will tell you what's going on with each of these in the properties. And then also you've got your watch window here that you can add watch things to. If you've got a large program, you can see what the internal and external LEDs are doing, etc., on each of your programs. There isn't currently a simulation for this program, but that's been worked on, I believe, in the background. And what we are What we can do instead is debug. So when the code's gone down, the diff code will go green, and we can actually connect back to the Opta and click on debug live debug, which we will do. We've got it set up here in the office, so you can actually get the data out, and we'll be able to show you the live debug. It's a very good resource to actually show what's happening within your program. As you can see, it's taking a little time to do. Can be a little bit frustrating, but it's worth sticking with it. The Opta is such a good product. And across the bottom, you have got your unfortunately it won't show because of the sketches. You have your resources, your variable windows, and your programs. And with the programs, you can add extra lines, so you can make this line bigger, so you can have the whole of this as one programming window. For smaller applications with function block, or for larger applications with function block, you can increase different networks and have a different network doing all different things. And also you can actually, within this as well, the master at the moment is a function block, but we could, if we wanted to, set up a ladder sketch, a ladder diagram, sorry, not a ladder sketch, a ladder diagram. So if you're more used to ladder, ladder can be run as well, and they can be run at the same time. So you can have a ladder sketch doing one part of a ladder sketch, doing one part of the programming, and a function block doing the other, and you can have a true scripted text sketch doing something else in the background as well. So they can all run at the same time. And they can interact with global variables. So you could have a structured text doing some scaling and things like that, and use that in different parts of your program. So as you can see, we're moving through. It's going down slowly. Unfortunately, it doesn't have an egg timer to say how long it's going to take. But as I said earlier, this is only happening for the first time you connect a new program to an Opta. As long as you've, when you're doing changes, it takes very few seconds. So as you can see, this is why the output is important. It is still moving forward. They are changing, so you can see the differences. It's also where you'll see any percentages of how far they are downloading it when it gets to updating the memory of the product. Being able to use the Opta as a master is the first step in to be able to produce a system that means we can actually pull the product data from the 6M, such as power consumption, etc., from a single phase or three phase. Do some mathematics to it, so we could pull it from three different single phase, so L1, 2, or 3 on the three phase supply, add them together to maximum current, and also it is possible with this product. We're only doing the pulling in the current value, but it has also voltage, apparent power, reactive power, true power, cosine, so the phase angle, frequency, and harmonic distortion. So it will lend itself to sort of genset manufacturers and things like that. And also it does have a non-volatile energy meter, energy management, so you can do that, and it has import and export. So here we go, it's uploading. Import and export values, so you can use it for green energy. So as you can see now, you've got the download, it's erased it, it's downloaded it, so that took a little while. So it's done all that now, so we're not connected, so we need to go back online and connect. So we're connected and everything's fine and dandy there. And if we go to debug now and live debug mode, we're in debug mode, and you can see that at the moment we've got nothing on. We'll try to turn it on, but sometimes it doesn't. So we've turned the heater on, and you can actually now see that actually we've got 2,600-ish milliamps coming in. We'll divide it by 1,000 to give 2.6 amps. If it's over 2 amps, we're putting an LED on. That could be a relay, it could be a sounder, it could be a siren, it could be anything. And if we turn it off again, you'll see it goes off. And you know, from here we could, if we wanted to, put a timer on to say, yeah, let's do that. You can put a timer on here to say don't, a delay timer to say turn it on if it takes too long. Timers are all found in the standard, so we can do a T on here, and we'll just call it T1, timer 1, and here we can delete this wire here and go to LED. We can then connect these two together, and we'll need a timing value which is constant. So if we put it's in milliseconds, let's put 1,000, let's put 500, which should be, so it's 500 times 0.1 of a millisecond. So now if we go, you'll see the code's different. If we do connect to make sure we're connected, and download it, you'll see it goes very quickly. So that's up and done, and you can see it connected again. So that's what I was saying earlier, it takes very little time to do it. Live debug again, and turn it on, and as you can see now, it took sort of a little time for that to come on. So that's really how we do that. Look out for more videos. We'll do this. If you found these useful, please comment, and hope that was of use to you. Thanks a lot. Cheers, guys.